Imagine the digital ether buzzing. A sensational headline flashes worldwide. Quantum AI detects singularity rift in James Webb data, discovered by our most advanced telescope, analyzed by an intelligence beyond our own. It sends shivers down the spine, a concept from science fiction. What could this mean for humanity? But let us pause. For now, it remains speculation. No such singularity rift has been detected. No quantum AI has issued such a warning. Yet the possibility ignites our imagination. It forces us to consider the frontiers of science. The James Webb Space Telescope is humanity's most powerful eye on the cosmos. It peers back to the dawn of time. Quantum AI represents a revolution in computation. The combination of these capabilities is something to ponder. While we ground ourselves in reality, let us explore. The universe has stories to tell. We are just learning how to listen. What exactly is this quantum AI, this supposed harbinger of cosmic revelations? It is not merely a faster version of the computers we use every day. Classical computers think in bits, ones and zeros. Quantum computers, however, operate on a different plane altogether. They use qubits. These qubits can be a 1, a 0, or crucially, both simultaneously. This is the mind-bending principle of superposition. Imagine a coin spinning in the air, neither heads nor tails until it lands. Qubits are like that, but with far more complex possibilities. This ability, along with another quantum phenomenon called entanglement, gives quantum computers their extraordinary power. Entanglement links qubits together. The state of one instantly influences the state of another, no matter the distance separating them. This interconnectedness allows quantum computers to explore a vast number of possibilities simultaneously. For certain problems, this means an exponential leap in processing power. They could revolutionize fields like medicine, materials science, finance, and of course, astrophysics. However, we must be clear. Quantum AI is still in its infancy. Building stable, large-scale quantum computers is an enormous engineering challenge. Yet the future gleams with potential. The James Webb Space Telescope is nothing short of an engineering marvel. It is humanity's premier space observatory for the 21st century. Launched on Christmas Day 2021, it traveled over 1 million miles from Earth. It now orbits the Sun at a special point called the Second Lagrange Point, or L2. This location keeps it cold and stable. Its giant gold-coated beryllium mirror, over 6.5 meters across, is a sight to behold. It is designed to capture infrared light, the heat signature of the universe. JWST's primary purpose is to look back in time, further back than ever before. Because light takes time to travel, observing distant objects is like looking into the past. JWST is designed to see the very first stars and galaxies forming after the Big Bang over 13.5 billion years ago. It aims to shed light on the cosmic dawn. The data that JWST sends back to Earth is staggering. It is a torrent of images and spectra, rich with information. This data represents a new window onto the universe. The telescope provides the vision, our ingenuity provides the understanding. Let us now turn to the concept of a singularity rift. First, what is a singularity in physics? It is a point where our current theories break down, a place where quantities like density or space-time curvature become infinite. The center of a black hole is believed to be a singularity. The Big Bang itself, the origin point of our universe, is also described as an initial singularity. These are regions where the known laws of physics, including Einstein's general relativity, no longer provide a complete description. A singularity rift, then, is a more speculative idea. It is not a standard term in established physics. However, one can imagine it as a hypothetical tear or rupture in the fabric of space-time itself, perhaps connected to these extreme points of singularity. Could such a rift be a gateway, a wormhole connecting distant parts of our universe, or even a bridge to other universes if they exist? There is currently no scientific evidence whatsoever for the existence of singularity rifts. They remain firmly in the domain of theoretical conjecture. Section 5. JWST's Genuine Marvels Unveiling Cosmic Truths. While hypothetical singularity rifts remain science fiction, the James Webb Space Telescope is delivering a cascade of real, awe-inspiring discoveries. It is rewriting textbooks. It is challenging our existing models of the early universe. Astronomers are finding galaxies that are far more mature and massive in the early cosmos than previously thought possible. These ancient stellar cities formed surprisingly quickly after the Big Bang. This forces theorists to refine their understanding of galaxy formation and evolution. Beyond the distant universe, JWST is revolutionizing exoplanet science. It is capable of dissecting the light that passes through the atmospheres of planets orbiting other stars. This technique, called transit spectroscopy, allows scientists to identify the chemical composition of those alien skies. JWST has already detected carbon dioxide, methane, and water vapor in exoplanet atmospheres. Each observation brings us a step closer to answering that profound question: are we alone? These genuine discoveries are transforming astrophysics. The JWST is not just a telescope, it is a catalyst for a new era of cosmic exploration. Section 6. The Quantum Leap in Data Analysis, Deciphering Webb's Secrets. So, how could future quantum AI, once mature, specifically aid in deciphering the secrets held within JWST's data streams? One key area is pattern recognition. The universe is full of complex patterns, from the large-scale structure of galaxy clusters to the subtle spectral signatures of molecules. Quantum algorithms could potentially identify faint or highly complex patterns within the enormous datasets from JWST. Patterns that might be invisible to classical algorithms or would take them centuries to find. This could lead to unexpected discoveries, anomalies that hint at new physics. Another powerful application lies in simulation. Understanding the universe often involves creating complex computer models. Simulating the formation of a galaxy, the dynamics of a black hole accretion disk, or the evolution of a planetary system requires immense computational power. Quantum computers promise to perform certain types of simulations far more efficiently than classical ones. This would allow astrophysicists to test their theories against JWST's observations with much greater fidelity. Section 7. Navigating the Noise, the Imperative of Scientific Truth. Let us return to the sensational claim quantum AI detects singularity rift. Why is it so important to address and debunk such pronouncements when they are not based on fact? Because misinformation, especially in science, can be incredibly damaging. It can create false expectations. It can erode public trust in genuine scientific endeavor. When fantastical claims are presented as reality, they overshadow the real, hard-won progress that scientists are making every single day. The universe is amazing enough without needing to invent fictions. Science operates through a rigorous process. It is built upon the foundations of the scientific method. This involves observation, hypothesis, prediction, experimentation, and verification. Discoveries are subjected to peer review, where other experts scrutinize the methods and conclusions. Results must be reproducible. This careful, iterative process is designed to filter out errors and biases. Sensational, unverified claims bypass this essential process. They offer a shortcut to wonder that ultimately leads nowhere. Therefore, there is a profound responsibility that comes with communicating science. Section 8. The Symbiosis of Mind and Machine Charting Future Frontiers. Looking ahead, the role of artificial intelligence, both classical and eventually quantum in space exploration, will only grow. It will become an indispensable partner in our quest to understand the cosmos. Future space missions, venturing further into our solar system and beyond, will rely heavily on AI. Imagine probes capable of making autonomous decisions light years from Earth. AI could navigate complex environments, like the subsurface oceans of icy moons, or identify transient astronomical events in real time, alerting scientists back home. AI will also be crucial in designing the next generation of telescopes and scientific instruments, optimizing the complex optical systems of future space observatories, developing new sensor technologies, planning efficient observation schedules to maximize scientific return. These are tasks where AI's ability to analyze vast parameter spaces and find optimal solutions will be invaluable. The machines will help us build better machines. This human-AI collaboration could lead to breakthroughs that neither could achieve alone. Section 9. Our Cosmic Destiny. The Endless Quest for Knowledge. The human spirit is intrinsically curious. We are driven by an insatiable desire to explore and understand our place in the cosmos. From ancient stargazers to modern scientists, this quest defines us. Every answer uncovers new questions. Each horizon reveals further horizons. This is the beauty and challenge of science. The universe is filled with wonders stranger than fiction, black holes that warp space-time, neutron stars with unimaginable densities, galaxies colliding in cosmic dances, the faint afterglow of the Big Bang. JWST helps us uncover these marvels. The future of space exploration is incredibly bright.